Okay, Assalamualaikum and good evening. My name is Muhamad Azrul Bin Razilan. I'm from RY 40 Group 3 and my matric number is 91913820069. So here, my name and another L. So let's go to presentation. Today I would like to present a let one is OM operation is OM operational amplifier. So this is my part A, which is the inverting amplifier. So this is my circuit is completed. So this is my schematic. So you need to choose the where? Okay, here. Uh you need to choose analog and choose the OM here and choose the A UA 741 for the part number. So let's go to the next step. Firstly, you need to click. So I will test my circuit first. Is have a error or not? So let's go. Yeah, you need to click the button run. So I forgot to tell you something. You need to put the probe first to run and get the measurement, and we stop it and we click the graph. It will show the sine wave for the inverting amplifier for 10 for 7 4.7 kilo ohm resistance. So here the measure we need to so let's go to next step for the 10k resistance. So we run it. So go to next step. This graph and get the measurement. We go through to the 3.3k. Okay, this is what for resistor 3.333k. It has a cut off here. It will cut off at 50. We call it voltage here and here. So we get the voltage and millivolt. So this is my calculation for 4.7 kilo ohm, and here for my 10k kilo ohm, and here for 33 kilo ohm. Okay, go to the question. Why is the output sine wave have been flipper? Output flipper can be caused by exceeding the input common mode voltage range, input in headroom, or the input differential voltage range of the amplifier. Flipper can also occur when the output voltage range of the amplifier is exceed. Exceed. What is the what Why is it called why is it called everything amplifier? Is called amplifier because the OM change the phase angle of the output signal exactly 108 degree out of the phase with respect to input signal. Same as like before, we used to external resistance to create feedback circuit and make a closed loop circuit across the amplifier. So we go to the so this is my part B, which is the non-inverting amplifier. So this is my circuit for resistance 4.7k kilo ohm. So let's go to next step. Firstly, we run it. I have run it and go to graph to get the sine wave, the sine wave, and we put the higher plot here and here, and we got the measurement, measure bacaan here and here, millivolt and volt. So we go to oh no, this is my measurement. This is my yeah. This is my non-inverting OM for 10k. My calculation here. I put the graph and schematic diagram. So let's go to 10k. Wait, I will change it first. Okay, run it to get the sine wave here. The sine wave. Oh no, it's not sine wave. It's schematic diagram for 10k resistance. And here is the sine wave. We put the same the before. We put the higher one and get the measure. So let's go to next step. Stop it first and change it to 3.3. 3.3. Okay. Okay, so we run it to get the next step. Okay, this is measure. This is my circuit run it. It's not it don't have a error. So we go through to the graph. Here my graph for 3.3k for sine wave. So we get the we call it cut off, right? Here and here. We get the measurement. First, we stop it first. Okay, this is my measure. Okay, this is my calculation for 10k and 3.33k kilo ohm resistance. Okay, the question: why is it called a non-inverting amplifier? Amplifier that produce an amplifier signal at the output having a similar phase as that the time applied input is known as the non-inverting amplifier. This is simply mean that for an input signal with a positive phase, the output is also be positive. The question for number 4, what does non-inverting mean? If a sine wave is connected to the OM positive terminal. Okay, this is my answer. Non-inverting amplifier is an OM circuit configuration that produce amplifier output signal, and this output signal of the non-inverting operational amplifier is in phase with the applied input signal. In another word, a non-inverting amplifier behaves like a voltage follow circuit. So this is my discussion for A and B and conclusion. For discussion part A, in a inverting application circuit, the operational amplifier inverting input receives feedback from the output of the amplifier. Assume the OM is ideal and applying the concept of virtual short at the input terminal of OM. The voltage at the inverting terminal is equal to non-inverting terminal. For discussion part B, a non-inverting amplifier is OM circuit that produce amplifier output signal, and this output signal of the non-inverting OM is in phase with a signal. Okay. In other words, a non-inverting amplifier behaves like a voltage follower circuit. This is my conclusion. Measuring the input resistance of the OM at both inverting and non-inverting terminal confirm a very high input resistance, allowing one to assume the input resistance approach infinity in assuming ideal OM will infinity gain. The gain is only depend on the ratio of the feedback resistance RF to the input resistance RF. Therefore, only load connected to the input terminal of the OM vs the feedback resistance will set the gain of the device given ideal condition. That's all for me. Thank you, sir. I hope you enjoy my video.